We will now rough the part using surface high-speed area roughing. Area roughing is designed to rough boss shapes, cavities, and pockets. When going from the outside inward, Mastercam changes the machining strategy as needed if the part includes some cavities. Area roughing is a 3D surface high-speed toolpath that efficiently removes the material using smaller depths of cut. In the 3D group, expand the gallery. Then select Area Roughing. Select Machining and click on Select Entities. Then triple-click on the solid body. Press End Selection. Change the wall stock to 0.03 and the floor stock to 0.03. In the Model Geometry page, you can select the geometry, surfaces, or a solid to be machined, as well as the geometry to be avoided. You can also set the stock to leave for both machining and avoidance geometry. Select Toolpath Control. Use this page to set tool containment parameters in the strategy used in the Surface High-Speed toolpath. Containment boundaries are used to control the tool's position around the boundary of your part. The boundary is a closed set of wireframe curves which enclose the area to be machined. Mastercam will not create tool motions that violate the boundary, regardless of the selected cut surfaces. For area roughing, if a boundary was not specified, Mastercam will generate a min-max boundary around the selected drive surfaces. This boundary can be adjusted. Change the strategy to From Outside. Then select Tool. Select Library Tool and click on Filter. Change the type to Bull End Mill and set the tool diameter to equal 0.5. Then press OK. Select the Bull End Mill with a corner radius of 0.125 and press OK. Enter the comment, rough out the part. The feeds and spindle speed are based on the tool definition. You can overwrite them with the feeds and speeds that you want to use based on the machine, the tool material, and the part material. These values are just a suggestion. For this tutorial, we will modify them. Change the feed rate to 200, the spindle speed to 15,000, the plunge rate to 100, and the retract rate to 200. Select Cut Parameters. Make sure Step Down is set to 0.05 and keep tool down within % of tool diameter 500. Optimize cut order keeps the tool in the local area until all depth cuts are complete. It reduces the number of rapid moves in the toolpath. Step down controls how the tool steps down in the Z non-shallow areas. Add cuts adds cuts to shallow areas. Mastercam uses an adaptive step-down procedure to calculate the cuts. Keep tool down within sets the gap settings for motion between toolpaths. XY step over controls how the tool steps in the XY tool plane. Select trochoidal motion and make sure it's off. Then select linking parameters. Make sure clearance plane is set to 2 absolute. Fitting is set to minimize trimming. And full vertical retract is selected. Clearance plane sets the Z safe height for the tool clear of any obstacles. Part clearance sets the minimum distance for tool motion above the part. Retract method set to full vertical retract creates a vertical retract move to the part clearance height. Linear entry-exit values are used to extend the toolpath at the beginning and end of the cuts. Extension is located after the entry arc and before the exit arc. Fitting method determines how toolpaths are modified to fit inside boundaries, walls, and other obstacles. Minimize trimming retracts as close to the surface as possible, maintaining sufficient distance to fit an entry-exit arc. Max trimming distance limits trimming for non-horizontal passes. Set this value at least as large as the entry-exit arc radius. Select Arc Filter Tolerance. Enable line arc filtering settings. Create arcs in XY. And set the cut tolerance to 30%. Press OK to generate the operation. Backplot the operation. When backplot is finished, press OK. Then click Verify. When Verify is finished, minimize the simulation window. Then toggle the toolpath display off.